Okay. So who was the first one? Who was the first one who joined this class today? So I don't
Sir,
think Wakas Saab was the first one, because it you will face the same problem again.
The recording is started, and I think if it saved in my Google Drive, I'll share it, inshallah.
सर मैंने रिकॉर्डिंग स्टार्ट कर ली है, मैं इंशाल्लाह शेयर कर लूँगा।
चले ग्रेट हो गया, चले ठीक है हम देख।
Okay. So should I start?
Yes, please.
Okay. First of all, I want to ask if there is anyone who can't understand Pashto, because I know
Yes,
many
please.
persons who doesn't understand Urdu. Salman, am I audible?
Yes, sir. Yes, sir.
Yes, we
Okay,
can
thank you.
clearly hear you, Mr. Wakas.
Thank you so much. Okay, so the presentation is about the very basics of a geographic information system. That may be a little bit boring for those who know, who have some know-how about the GIS, geographic information system. But for those who are very new to this software and this subject, that may build some basic concepts of them about the work they'll be doing in GIS in future. So first of all, what is the abbreviation of the GIS? GIS is the Geographic Information System. Geographic Information System, if we further study the word geographic, it's the combination of two things, the geo and graphy. The geo means earth and the graphy mean measurement. So the measurement of different things over the earth is called the geography. And GIS denotes the concept of spatial location. What does it? Most of the time when we are working with GIS, we discussed it again and again. We listen this word spatial again and again. So whenever there is a word spatial, it simply means that, for example, if there is a spatial data, it means that data includes the location of to which to of the points to which those data belongs. For example, if I say that the building's spatial building data means that that data will include the information of location of each building. Earthquake, special earthquake data means that each point of earthquake will include its location. So whenever we are working with GIS, we have to work with a spatial data, which must include its location. Is it clear?
Yes, sir.
Yes,
And
sir.
okay, and geography means the patterns and processes of human and physical phenomena of Earth's surface. So the first thing is it? I think it's clear that the measurement of Earth and the different phenomena of Earth, which includes its location. For example, earthquake on Earth and its location, population of on Earth and the location of those population, buildings on Earth and the population and the location of those buildings. So any data which includes its location on a surface of Earth, we can work on that data through GIS. The second word is information. So information means there is normally we enter use the word data and information, but there is a basic difference between data and information. When we says, for example, if I say one, there's data 1, 2, 3, 4. That's a data, but this 1, 2, 3, 4 tells us nothing. It's just different numbers. But when I say that roll number 1, roll number 2, roll number 3, now I know that 1, 2, and 3 are representing someone. If I say that roll number 1 of a postgrad class, now I know that this roll number is representing someone from the postgrad side of UT. For example, if I say that this is the roll number 1 of the GIS class of postgrad from UT Peshawar. Now, when I include the context and a background with the data, then we call that data an information. The context and the background of any data actually transform a simple data into information. So in GIS, basically we work with information, the data which have some context, which includes its location, which includes its relevant information. And a system means that we give some input to the GIS, and we run some analysis, and after that analysis, an output which is required to us as per our analysis is given by the GIS. So I think the basic concept of geographic information system may have some clarity in your mind now. So now again, as I told you earlier, that in GIS basically we work with spatial data. So spatial data means that any data which includes its location, and the location is basically based on projection system and geographic coordinate system. Like we have geographic coordinate system, we have projected coordinate system, which will be touched a little bit in this lecture laterally. For example, this point, if I don't have any location information, if I have a point, for example, if I have a building and I don't have any location information of that building, I may don't know that where this building belongs and what are the surrounding condition of that building. For example, in which area if the earthquake occurs, that building will be suffered, and in which area flood occurs, that building will be suffered. For that all analysis, first of all I need to know the location of that specific building. And now how I will know the location of that building? I have to incorporate the spatial information, the location, the coordinates of that information, and that data. Is it clear?
Yes, sir.
So what is a GIS? A GIS is a toolbox, and that toolbox we actually worked with layers. For example, if this is the real world, we can represent this real world in different layers of GIS. For example, the first layer of GIS, which is a raster layer, I will let you know about the raster and vector layers later on. Or let me explain that we have two basic types of data. We have further types of data, but we have basic types of data in GIS. One is raster data and the one is vector data. And vector data, we further include three parts: points data, like this is points data; line data, like roads and canals, and these are line data; and polygon data, like building boundaries and such type of polygons. This is called polygon data. So these three are the types of vector data. And in raster data we actually include those type of data in which the information is given in the form of pixels. For example, this green pixels, this yellow pixel, this red pixel. So the elevation data, for example, the digital elevation model of an area. Digital elevation model of an area for means that that data actually includes the relative height of different points in that specific area. So the elevation data is just normally given in raster format. The imagery is normally in pixel format, so that is in raster data. So we have two basic data types: the raster data and the vector data. The raster data includes all those data which is in the form of pixels, like pictures, like digital elevation model, in the rest of the things. And the vector data includes the information about buildings, about roads, and about the boundaries of different areas and provinces and districts. Is it clear?
Yes, sir.
Yes, sir.
Okay, and the next thing which you will see in the GIS is the attribute data. The attribute data is like the context. For example, if I told you that this is roll number 1, so roll number 1 of which class, which department, which university. So the context and the background information is actually provided in the attribute table, and you will see it later on when I will open the GIS software. So history of GIS, the major history of GIS: era of innovation 1950 to 70, era of commercialization 1980 to 1990, era of exploitation. Like in 2013, a report shows that the annual revenue of GIS software is $270 billion, which is a lot of money, and it shows that the efficiency and the productivity and the importance of GIS software. $270 billion is a hell of money, and with the growing rate of 10 to 15% annually. Like if we cross check it now, its annual revenue must be more than $500 billion, which is a lot of money. And it actually shows the importance of this software, that how much it is actually used in the field. So Importance of layers in GIS: geographical data representation of reality. Reality is complex. Okay, so and that to make that reality, that complication simpler, we work with layers in GIS. For example, I told you in this format that, for example, the building data, let's suppose, or the customers or the building data are in one layer, or the population is in one layer, the street data is in another layer, the boundaries data is in another layer, the digital elevation of that area is in another layer, the land use, like how much land is used for agriculture purpose, how much land is used for commercial purpose, how much land is used for residential or houses purpose, how much land is used for the rest of the activities or industrial and this type of activities. That information is given in a separate layer. So GIS basically work in layers. So you have two type layers basically: raster layers and vector layers. Is that clear?
Yes,
Yes.
please.
Oh. So this is imaginary, then imagery, then elevation, then transportation, then addresses, boundaries, water features, survey, control your data. So real world is actually distributed in multiple layers, and this multiple layers must be aligned in a specific way. For example, if the land use data is placed above the building data, the building data will not be visible. If the land use data is placed about the population data will not be visible. So when you are working with layers, you have to align those layers in a specific order. So the data which must be on the top must be on the top, and the which data which must be in the lower bottom must be in the lower bottom. And how we'll do that in a GIS software, we'll see in the lateral part when we are working with the software actually. Okay. Now the next question is why GIS is different from other geographic information, other graphic system. If, for example, we are working with CAD, we can do only mapping with CAD. We cannot do any type of processing or analysis with CAD. So GIS actually provide you a data management system. Like it can do the work of Excel. You can store data. You can, like, the attribute table is a part. The structure of attribute table is like an Excel sheet with columns and rows. So you can feed or you can save data in the attribute table, which is like the work of a Excel sheet. Analysis capabilities, it always also have analysis capability. You have also worked with the different things, like you can selection by expression or intersection or the rest of the thing, buffer, and you will do watershed analysis in the rest of the thing. Spatial georeferencing, you can actually locate the data on its exact actual position on the surface of Earth, which is not is the case with CAD, and the graphic output, which is the case which can be better done by CAD. So in a specific area, this software may not be able to do the work as with as high quality is done in that specific like CAD software or any other software. But if we are working but if we look into the multiple capabilities of GIS, that's the uniqueness of GIS. It can do multiple things. It can do a data management system work. It can do analysis capabilities. It can do georeferencing. It can give you a graphic output. So this is it. So you can do mapping, measurements, monitoring, modeling, and management with GIS. And this is what you can do actually with land use management, resource inventories, watershed analysis. And I think we will be practicing many of these activities in the coming classes, inshallah. Now, another important thing is the projection system. Like when we are working with GIS, we have to choose a projection system. For example, if a coordinates are given, there are multiple projection system. When our coordinates are given, we must know that for the specific area, what is the best feasible projection system. But first of all, what is a projection? Coordinate system. A coordinate system actually tells you about the location of points on the surface of Earth. Like you can see, the Earth is distributed based on these and these lines. And these lines actually form some squares on the surface of Earth. And each square or each point on this surface have some numerical value in terms of meters or in terms of degrees with respect to these lines. So for example, if I have a building and I know that what is its distance from this line and what is its distance from this line, I can locate it on the surface of Earth. And this is the purpose of coordinate system. So one is geographic coordinate system and the second one is the projected coordinate system. The geographic coordinate system is basically based on angles like degree, minutes, and seconds, and the projected coordinate system actually works on distance like meters, units, and inches. And basically, a projected coordinate system is the 2D transformation of a geographic coordinate system. For example, the globe is in a 3D format, and when we are representing that 3D in a 2D dimension, like a map, so that is the projection of this geographic coordinate system. Is that clear?
Yes,
So
sir.
okay. My measurement latitude, longitude usually use, in this case we use meter, feet, inches. Distortion will occur, for example, there's this curvature in earth shape. If we consider it as a sphere, for example, so there is a curvature. When you are working with a projected system, you actually take it like a flat area. When you are taking it like a flat area, you are actually ignoring that curvature. So for a short area, for a limited area, the distortion may not be very significant, but when you are taking a big area, the distortion will be significant in that area, and that will cause some errors in your projected maps. So latitude and longitudes, that was explained by Dr. Asif sir in previous class, but I will repeat it for Kamran sir and some newcomers which may not have taken that class. Basically, the Earth's surface is divided in vertical lines, which are called longitudes, and horizontal lines, which are called latitudes. So whenever for example, if I say that a point is located at 35 northing and 50 easting, so it means that the northing direction is that the northing is basically the angle from this equator, from the latitude. So 35 northing means it will locate it somewhere here. When I say that it's 50 east or west, so 50 east means it's located somewhere here. So in the north direction from the equator and from the prime meridian towards the east with a 50 degree. So we can actually locate any point, any building, on anything on the surface of Earth based on latitudes and longitudes. The prime meridian, which passed through the Greenwich point of England, is the 0 point for a longitude, and the equator is the 0 point for a latitude. And basically, the temperature zones of the world are basically based on equator. The countries which are near equator are warmer as compared to the countries which are near poles. And from the Greenwich prime meridian, the time is actually calculated or measured from the world. For example, if the time at the green meridian is 2 p.m. in Pakistan, the time will be 7 p.m. because the GMT plus 5, you may have seen it multiple times. Pakistan is at 75 degree from prime meridian. So each 15 degrees actually count for 1 hour difference. So if the time at the Greenwich is 2 p.m., the time at Pakistan will be 7 p.m. because the total longitudes are 360, and if we divide 360 by 24, it's gave us 15. So it means that if a country is at a difference of 15 longitude from your country, the time difference between your country and that country will be 1 hour. If that difference is in the east direction, then it will be a positive. For example, if your country is here and the second country is at 30 degree in the east direction, so if this is 2 p.m., there will be 4 p.m. But if the direction is west of that country, then if there is 2 p.m., there will be 12 p.m. Is it clear?
Yes.
Yes, sir.
Thank you.
So this was the concept of longitude and latitude. So we now know that we have two basic types of data, vector data and raster data. Vector data have three subtypes: point data, line data, and polygon data. And raster data actually includes multiple, like digital elevation models, like imageries, which includes pixels. And for the context or background information, we have a database like another sheet which is called attribute table. Is it clear now?
Yes, sir.
Okay, so I will move towards the software, and so with this some basic step, and then I will leave the presentation to Hidatullah. I don't know who the second one. So is this being?
Kotas, can I add a couple of points?
Sure, sir. Sure, please. Thank you.
Yeah. Okay. Thank you. Let me add a couple of points for latitude and longitudes because this is quite a critical thing for understanding our GIS and other GIS softwares. These are basically two angles. One is horizontal angle and the other one is vertical angle. If we are talking about horizontal angle, what is the reference? The reference point is center of the earth and equator. If we cut whole of the globe or world into two pieces horizontally, then the central line is known as equator, and that center of the earth is our reference point. Now, if we measure horizontal angle with reference to center of earth and surface of earth, that angle will be known as longitude. Whereas if we measure vertical angle between center of earth and surface of earth, the angle will be called as latitude. As we know that in engineering, for example, if we join multiple points of same altitude, then we call it contour. Similarly, if we join multiple points of same pressure, we call it isobar. Similarly, when we join same temperature points, we call it isobar. So now what we are going to join, same angles, point of same angles. So if the points of same angle of horizontal angle, for example, then this will be known as meridian, and horizontal angle was longitude. Okay, so longitude is horizontal angle, and same longitudes will form meridian. Similarly, if we are talking about latitude, latitude is vertical angle, and same vertical angles if joined will become a parallel. So there are two type of lines, parallels and meridians. Parallels are linked with climate. For example, if we are at the equator, which is zero parallel, so what will happen? There will be extreme hot weather. And if we go to North and South Pole, there will be cold weather. So something in between will be moderate, and you will be thinking that how weathers are rotating. This is just because of the tilt angle of the Earth, which is around 23.5 degrees. So there is revolving condition of the Earth around its own orbit and around Sun. So around its own orbit, when it rotates, it causes the difference in seasons. And there will be two lines, which is Tropic of Cancer and Tropic of Capricorn. And just because of those tilt and two tropics, we are feeling these weather differences during various months of the year. So now what you have to remember that latitude and longitudes are vertical and horizontal angles, and if we join vertical or horizontal same angles, we will get meridians or parallels. Parallels are linked with seasons, whereas meridians are linked with time. So this time thing has already been explained quite in detail, so I'm not going into that particular detail again. And I believe you will be able to understand the other bit as well. So please continue, Wakasa. Thank you.
Thank you, sir. I think the screen of GIS is visible to you all. So this is where for when you double click the arc map available on your desktop or from the side window, this screen will be opened. So for example, I'd make it simple, and then I'll show you different things. Okay, so if none of the tools is open, and your GIS, your interface will look like this. If you need different things, for example, if you need the side window to handle different layers uploaded, you can open that from window and table of contents. Window and table of contents. Click it, and the table of contents window will be open on the side of your GIS. Same is the case if you need any of the tools for any, like for example, you need an editor tool or you need a sample tools, any other tool, you can right click on this place, right click. For example, I need simple tools. I just clicked it, and here are the simple tools, like you can see it. If I need the editor tool, I just checked it, and here is the editor tool. If I need the geo-referencing tool, I can just check it, and there is the geo-referencing tool. You can move these tools as per your requirement to adjust your screen. Like for example, okay. So you can open different tools. I just open some of them which are required in a process. And this is. Okay. Now, the second important thing is, especially for the beginners, is that how to upload data. And if you need to upload data, you basically need the standard tool. This is the standard tool. Now it is here on your screen. Okay. Check the standard tool from here, and it will be available at your tool window. So if I want to add data in ArcGIS, first we have to make a connection between that folder and your software. And if I want to make a connection, I can add data from this plus sign, but there is, like, I just clicked it, and it's directly moved to the folder which is already connected with my software. Okay, but there is a better way. You have to go toward this catalog. Just click this catalog. The catalog is open. Now at current stage, there are two folders connected by my software. The first one is on the desktop, and the second one is in my Dropbox folder. I can disconnect this folder. For example, if I can disconnect this folder, and now I want to connect that folder. For example, if you have a folder in your system where all the maps and the rest of the things are currently are in that specific folder, you can just click this connect to folder. Connect to folder. My folder is on desktop, so I'll click desktop, and this is the folder I want to connect with. I just clicked it. Okay, and here the folder is now visible. Is it clear? Especially for the beginners.
Yes, sir.
And just by dragging it down, you can see the layers available in that specific folder. So in my specific folder, the earthquake data is available, the Pakistan boundaries are available, and the Pak cities, like the boundaries of different cities of Pakistan, are available. So I'll just grab it and move it towards the window. Is it clear?
Yes, sir.
Okay.
Sir, I have a question here.
Yeah, you can ask,
Sir,
please.
the main difference between ArcCatalog and ArcGIS.
ArcCatalog is just a tool of ArcGIS. ArcGIS or ArcMap is a software, and there are multiple tools to which help you out to run different analysis and to work out different things. Like you can do the hydrological modeling, hydrological analysis, and the rest of the things. So ArcCatalog is basically a connector between your software and the folders, in simple words. Is that clear?
Yes, thank you.
Okay. So now if this table of content, for example, what I'm trying to say, when I was a beginner at this software, the problem I have always issues to connect with the folder. And if there is any window missing, I was at that stage, I was struggling to find out that specific table of contents or any window. So for example, if this window is not available, I just closed it. I can open it from window. And if any other window is not available, if any other tool set is not available, I can just make it visible on the screen with this right click and this checking. Is it clear? Okay. So with this pen, I can, if the pen is clicked, I can move it right left. By this, I can, if I want to specifically zoom this place, so I'll just drag it and that place will be zoomed. If I want to make the whole map visible again, I will just right click here and zoom to layer. Okay, and if, for example, I do this, I can directly do this with this full extent as well. Okay, so I can zoom out and zoom in and the rest of the things with this software. Now, what is this is basically a polygon map. This is basically a polygon map, a type of vector data, a polygon map. And if I bring this earthquake data over here, this is basically point data. Okay, if I want to remove any layer, I can right click on it and I can remove it. If I want to zoom this specific layer, I'll just right click and zoom to this layer, and now this layer is visible. Okay, if I want to remove this, I just removed it, and I want to bring it back, I'll just click it and it will bring it back. Okay, this table of content is now visible. We can directly do it from here as well. So this is basically a vector data and a polygon type of vector data. And if I want to see the background information, the context of this map, I can just right click here and I can open the attribute table. When I opened the attribute table, what information it have? It's a polygon shape. The country is Pakistan. The different provinces are this in name 1. The divisions are given in name 2, and the cities details are given in name 3. Okay. Normally, you may have seen maps with multiple colors. If I want to show each province with a different color, and if I want to name it based on its division, or I want to name it based on its city name, I'll just right click here. Okay, I'll go to its properties. Okay, so these are the properties. Okay, if I want to show, there are different things: general information, source information, geographic information system, and the rest of the things. Display. If you want if you have multiple maps and you want to make the top layer a bit transparent, so you can make it transparent from here. For example, if I make it 50% transparent, you can see the map is faded. If I remove this transparency, the map is with the same color again. So if I want to have different color for each province, I'll just come here to the symbologies, the categories, and the first one is there. So was for a single color for the whole map. I want to make different provinces look with a different color. So I check the categories, then I'll check the provinces information were given in name one, as we always already checked the attribute table. If you want to make it look better symbologically, or you want to level it, you must have the know-how of the attribute data. So whenever you are going to work with the properties, first go and check out the attribute table. So the attribute table name 0, name 1, name 2, name 3, as I want to make its color based on its provincial names, so that that information is given in name 1. I'll close it, I'll go to its properties, and I'll go to from single symbol to categorize, and I will choose name 1. Now I'm telling the software that you have to categorize or make its symbology based on name 1. Once you check that, click this add values, and the different region will be colored as per this color. For example, if I want to make Azad Kashmir of any other color rather than green color, I can change its individual color as well. Now done, I'll apply, and you can look at the map. Is that clear?
Yes.
Yes, sir.
Now I want to label this based on its each city is given and the name 3. I'll go to the labels. Have to wait a little bit. And label feature in this layer, I will just check it based on what? Based on name 3. And if you want to have that name in black color or yellow color or bold style or big, you can change the text and the rest of the thing as well. I want to have that name in a bold text, for example, with uh, size increase. For example, I just keep the size as it is. So I just applied it, and you can see that the name on each place is now mentioned. Is it clear?
Yes, sir.
Okay, now I will do a little bit of work with earthquake data. So I just bring it here. Okay, if why did I told you that the alignment is very important? Earthquake data must be visible, and for its visibility, its layer must be above on Pak cities. If just drag it down, now the earthquake data on Pakistan map is not visible. So when I need to make it visible, I'll drag down the Pak cities, and the earthquake data is not visible. So now I'll just, there are two ways. If I don't need this Pak map, I can rather remove it, and in case of removal, it will be completely removed from the software. But if I want to make it stay here, but I just don't want to see it now, so I will just uncheck from here, and this uncheck will disappear the map from your screen. So now I have the earthquake data. I've just zoomed to the layer so the whole data will be visible, and I just want to see its attribute table, that what sort of background information is available with this earthquake data. So when I open the attribute table, the information available is the latitude and longitude. As I told earlier, that there must be the information of location, then the magnitude of each point, then the depth of each point, and then the month, day, and year in which this earthquake occurred. If, for example, this data is basically from 1973, and the data is too much. If I want to see that from which year to which year this data is, I can just click here, right click, and sort ascending, and now descending. So you can see that the data is from 1973 to 2012. What if the depth is more? The earthquake is less effective. If the depth is less, the earthquake is more effective. If the magnitude is more, the earthquake is more effective. If the magnitude is less, the earthquake is less effective. So for example, I want to know about the magnitude of each point and the depth of each point by just looking at it. So I will symbolize and label both. For example, I will symbolize it based on magnitude and I will label it based on depth. So by just looking to it, we have then an idea that what is the magnitude of that point, and from the label we can simply see the depth of that point. So I'll just zoom it so it easily visible. I'll just go to the properties. I want to symbolize it's based on its magnitude. Okay, so first I'll go to the symbology. From single symbol, I'll go to the categories, and I want to symbolize it's based on the magnitude. So I chose the magnitude, add value. So here the lower value will be shown, the points with lower magnitude will be shown in green color, with medium magnitude or average magnitude will be shown with yellow color, and with high magnitude will be shown with red color. Is it clear?
Yes, sir. Can I have a question, sir?
Okay, you can ask, please.
Sir, if we go more basically, for it will help the beginner learners. How can you make a shapefile in ArcGIS? And what will be the difference between shapefile and image file?
Okay, NetCDF files are generally used for raster data, like when you are working with rainfall, gridded data for rainfall and for the rest of the things. And shapefile is the basically when you are working with vector data, like road data, simple in terms of line, buildings data in terms of points, for example, and boundaries of district, for example. Currently, we are working with vector data, shape files. If you are interested to create a shape file, I think that will be better if we first georeference a file and then create a layer about that file. But for example, if we want to, but at this stage, I think that will be not good. Let's work with the basic, that how to upload data, how to symbolize it, how to label it. These are the basic things, how to connect a folder, and those are a bit advanced. So if the person who will be doing the georeferencing, if we georeference a place, then on that georeference page, we can create some points, we can create a line, and we can create a polygon. So I think that will be better. Is it okay if we go that way?
Yeah, it's
Okay.
okay, sir.
Okay, thank you. So I symbolize it based on its magnitude. So the lower magnitude values are shown in green color, with the medium magnitude values are shown in yellow color, and with the high magnitude values shown with red color. I just applied it, and just by looking at that data, you can simply say that which points are with more magnitude. So most of the points are in green area, some with the yellow area, and a very less point at the red area. So it means that most of the points are with the low magnitude earthquake. Now I want to label it based on its depth. So I'll just go to the labels. I'll just label feature in this layer based on its depth. I'll apply it. You can see that it will be labeled now. Look at this. Is it clear to you?
Yes, sir.
Okay. I think this was the basic part from my side. I can do a little bit more. If, for example, I will just do a single step for your help. And for example, I want to know those points which have the magnitude more than 4, for example. So I can select that by simply selection, select by attributes, okay, and select by attributes. I have different attributes. I will choose magnitude equal to, sorry, magnitude greater or equal to what? For example, if I choose 4, so I will apply this. So these points which are highlighted have magnitude equal to or more than 4. I can just right click, data, export data. I will choose the folder where I want to save it, desktop, and that folder was for today practice. Okay, I'll give it a new name, EQ data, magnitude greater 4. Okay, this is not EQ data 4. I don't know why it's not connecting with the folder. Let me check it again. This, okay. Okay, I will save it with already connected folder as it is generating a bit issue with connecting with the folder. Let me check it again. Want to connect with this folder, lab data. Okay, I want have to be a shape file, earthquake data for magnitude, save. Why? So there are some connectivity issues. Okay, I'll save it as it is. I don't know what's the issue with this. Okay, I'll choose this. Data, export data. Okay, it's saved now. So it will export the points. Yes. Now if I remove this, just give me a minute. This point, these are the points with magnitude with 4 or greater than 4. For example, if I check its attribute table, you can see that there is no value less than 4. So you can choose different points of your choice from earthquake data, from building, and from the rest of the thing. For example, if I want to choose all those points with an earthquake in 1973 or 2012 or anyone, I can choose that by simply going to by selection through attributes. So is it clear now? Anyone?
Yes, sir. Yes,
Yes.
sir. Bilkul.
Okay. So now I will hand over the leading seat to Hidayatullah. I think he's the second one who has to deliver his part. Thank you.
Okay, thank you.
Hidayatullah, are you here? Okay, thank you. Hidayatullah, am I audible to you? Okay, thank you. Okay.
Hidayatullah, bhai, we can't hear you.
Hidayat, turn on your mic, please.
Hidayat, you have to turn off your mic.
Yes, sir. My mic is on.
Okay, now you are audible
Okay,
now.
now.
Okay, thank you.
Yes. Actually, introduction to GIS and remote sensing was presented by Engineer Waqas. I have made.
I
I
want to
want to
introduce
introduce
some
some
basic
basic
features
features
of
of GIS.
GIS. In
Turn off one of them.
Excuse me. Dad, can you turn off the mic of your computer or phone?
Am I audible?
Yes, sir.
Yes, but it is repeating itself.
How is it now?
Now it's okay.
Yeah, it's fine. Go ahead.
Excuse me. So some of these basic features are also the teacher gave information about that. So I want to present some of the remaining features. So let's go to ArcGIS. As there are many toolbars in ArcGIS. So I want to introduce some of the basic toolbars which are used in many general mapping. One is the standard tool, and the other one is the tools. So I will explain some essential feature in these tools. So first, let's start from standard tool. So if you want to open a new GIS project, you can click this icon. By clicking this, you can insert a new template. And the other one is open. You can open a project by this icon, and you can save the project, and you can add data like layers, shape files, and many more. And you can add the catalog, help, and arc toolbox from these as well. So let's go to toolbars. Let's add a map to GIS. Let's these features are also introduced by Engineer Waqas. So I want to move to them, and I will present some of the remaining. So let's how can we define the coordinate of a point? You can identify the coordinate of a point by this icon, identify. So I want to identify the coordinate of a point in this map. Let's zoom it. Let's find the coordinate of this point. Now this window opens, so you can see that the point coordinate is in meters. So how can we change it to DMS, degree minute second? So let's point degree minutes, degree minute second. You can see that the coordinates are converted to degree minute second. So we can copy it. Let's copy this coordinate, or you can convert to degree decimals. As you can see, it's degree decimal minutes, and you can convert to degree decimals. Do you hear me?
Yes, yes.
Yes, yes.
Yes.
Let's copy these coordinates to Excel. These are the coordinates of the point. So let's isolate these coordinates. So this was the identify tool, how to identify a point coordinate. So let's zoom out. How can we find that point which we find the coordinate by GIS? So let's this is another feature, actually a good feature. So how can we find a point on GIS by a coordinate? So let's click that point, that XY feature. Here it is X and Y. So X is longitude and Y is latitude. So as we have coordinates, latitude is 31.61894. Let's copy it and let's paste here. Excuse me, let's paste here. And Y coordinate, you can as we paste the coordinate or enter the coordinate, you can flash the point. Sorry. This is actually X is longitude, Y is longitude. Let's copy again it. And this is latitude. You can now check where the point is. Oh, I don't know why it isn't working.
I think you have to add values of meters here, not in degree.
Sorry. Let's change.
Change the
Let's
system to
change.
decimal degrees.
Yeah. Let's change the system coordinates to decimal degrees. Properties, system general. Let's decimal degrees. It's here. Apply. Now you can see that the system coordinates change to decimal degrees. Let's try again. Let's try again. Let's copy that point coordinate. So let's take another point coordinates. I don't know what's happening with it. Let's take another point coordinate. Let's take this point coordinate. You can see that it's decimal degrees. It's copied to Excel. XY coordinate. Let's delete these coordinates. Control C. V. I don't know why it's not working.
Hidayatullah, in this window of there is written as meters, so you have to put the coordinates in meters.
Here?
Not here. When you click this, find XY. Now, so here it's written
Here,
meter.
yeah.
So you have to put values of meters here in X and Y.
Yeah, great. Right. Meters. Let's insert a new map. So it's a new map. Let's insert on that. This time let's change the coordinate system to degree decimals, decimal degrees, and now let's identify a point coordinate. Here it is. Let's convert to decimal degrees. Here it is. Let's copy this point. Let's identify that it's here again in meters. Oh yes, let's convert to decimal degrees. Now it's okay. So let's enter the point coordinates. The Control C and the Control V. The Control C, Control V. Now you can flash the point coordinate by this icon. Now it's working. You can add a point to that point. Now you can see it. Can you see it?
Yes, thank you.
Yeah, this was the point which we identify, and now we find in ArcGIS. You can enter every point coordinate in the world to find that point. For example, you find a location by GPS and you want to find that point. You can come here and go to XY and enter its coordinates you can find in ArcGIS. So you can add a point to that point. You can see it that you can add a point. You can add the coordinate of that point, and you can add a comment to this point as well. Let's delete these. Do you have any question? Do you hear me?
Please continue.
Yeah. Let's another feature. Another feature is to measure a different feature in ArcGIS. You can measure by this feature. So let's measure length. This is you can measure by this icon. You can measure length of a feature in GIS. Let's click here. Let's find the distance between. Let's find the distance between this point and this point. You can see that the distance between these 2 points is 306 meters. Here actually there are two lengths. One is segment length, one is total length. The total length is the length from this point to this point, and the segment length is when I move this point, the segment length increase as the total length also increase. So the total length is 5,816, and the segment that is not clicked yet is 696 meter. So how can we find this length by another units like kilometer, miles? So you can change here. So you can change distance to kilometers. Now you can see that the length is 7 kilometer, and the segment length is this length that is moving around. This length is 1.6 kilometer, and the total length from this point to this point and the segment is 7 kilometer. So you can measure area per feature. So how can we measure the area per feature? You can click this point. So if you want to measure the area of this feature of this area, so click, 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 click. You can see that the area is in square meter. So let's change to hectares or kilometers square. So you can see that the area is 22 square kilometer. The perimeter is 20 kilometer, and the segment length, the segment is the same as in the length one. So let's how can we measure a feature by just a click? So let's click this icon and measure a feature. By this feature, you can measure a length, an area of a feature by just one click. Now you can see that the area of this area is 19 square kilometer, and the perimeter is 20 square kilometer. So let's go to layout. As we have finished the project, we should go to layout and check the view of the view just before front, and we can also add some feature to the map as well. This little icon represents the layout view. Let's click the layout. You can see the layout view. So let's zoom the map. Now it's zoom. So you can change this paper size and from landscape to portrait. Let's change this map from landscape to portrait. Just simply click right click on the screen page tab and just click portrait in order to change change the size, change the paper. So you can see that it's a portrait paper, and you can also do it by file menu and page and prints tab. Here it's the same window. Let's again turn to landscape. Now you can see that we can convert from portrait to landscape. Let's add some essential feature to the layout view. Insert, you can you can insert title of the map. Let's write Kandahar city map. Insert title. Here it is. Now you can drag and place place where you want. So it's a title, so it will be on the top of the paper. Let's add text. You can add text as well, like notes and other text. You can add these as well, and you can move. You can move down. Let's add another feature to the layout view. This is dynamic text. This text change automatically with the time and the date. Now let's enter current date and its current date. Tomorrow it will be 6 date. So let's you can add current date, current time. You can also add current time. 1 minute later it will be 3:25. It's dynamic, it's automatically changed. So you can add legend. As there is only one layer, so one layer legend will be visible now. You can see the legend of the map. Let's add north arrow. North arrow, enter. This is the north arrow, which are always visible, available in different kind of general map. You can also insert a scale bar. There are different kind of scale bar, so you can select any one. So I want to select this one. And let's scale text. Scale text, I want to show that 1 centimeter in this map represent 10 kilometer in on Earth. So I click that, and it's you can see that 1 centimeter in this map is equal to 1 kilometer on the real world. So let's now you can print, you can export this map to PDF or GPG. Let's export this map to JPEG. Export. You can select the resolution of the map. Let's have a higher resolution map, 1000, and its pixel will be 11,000 in width and 8,500 in height. Let's save on desktop. The more the pixel, the more it will take times to proceed. Let's check. Let's check the map. You can see that a map is exported from GPS to a GIFIC. GIFIC. You can zoom in a lot more because it's a high resolution map. So you can export a map with low resolution as well. So let's how can we save? Let's back to data view. How can we save this this project? You can save by going to file menu, save. You can only save this file in only one format. It's ArcMap 10. So if someone want to save this map in any other version as well, so you can go to file and save as a copy. You can save, and here are the options. You can save this project as ArcMap 8, ArcMap 9, ArcMap 9.2, ArcMap 10, ArcMap 10.3. So every format you would like, you can save this project in that format as well. Do you hear me?
Yes, Mr. Radhala.
Yes.
Yes.
Let's add grid to this layout. So right click on layers, properties, grades, new grid. You can name it. Next, you can give intervals between longitudinal and latitude, a greater interval. Let's give it 2 degrees. 2 degrees. Next, finish. You can see that the map is graded, and let's remove these grades and decrease the amount of grades. So you can do it by right click and grade properties. You can delete or remove the lines by this icon. Do not show the lines in ticks. So let's decrease the axes as well. So I want to have only 2 axes. I want to remove top and right, only left axis and bottom axis are remained. So and you can change the size of the coordinates. Let's 16, and color of the coordinates apply. You can see that the color of the coordinates has been changed, and the grid lines are now no more there in the map. So one thing from my side is remaining. So how to determine the coordinates of a feature. So you can determine the coordinate of a feature or a map by right clicking on the layers, properties. This is the coordinate system. So as this map is already special has special coordinate which is WGS 1984 UTM zone 41. So if there is no special coordinate, you can select a coordinate from this list as well. So it's all from my side. Thank you.
Thank you, Hinayat, and thank
Thank
you,
you, Hidayat.
Wahab. Thank you.
Welcome, sir.
Who is next? Zaryab, I believe you are next, so you should share the screen and continue. Thank you.
Sir. Hello, sir. Able?
Yes,
Hello.
sir. Yeah.
Oh,
Hello.
okay, thank you. So, can you hear me properly?
Zaryab, if you are not ready, I can proceed the floor.
Okay, Salman, I just wanted to know if you can hear me correctly.
Yes, we can hear you clearly.
Thank you. Is my screen visible?
Yes, it's visible. Go ahead.
Yes,
Please.
yes, yes, yes.
Okay, thank you. Thank you. So here is our GIS software, and we'll go through the topic for georeferencing. So now, why do we need georeferencing? Because when you have an image and you don't have any reference to the real world, so then you georeference it to the real world via some control points. So let's start just directly. So first off, we have to add the data. We have to first link our folder. Now, let's say we have this data over here. Now, as you can see, there are some control points given saying it is 68° east and 37° north and so on. But it doesn't actually have any reference to the real world. Like when you hover over your pointer, you cannot see you can see there's written unknown points, and these coordinates are not related to the real world. So for that, what we have to do, we have to perform is georeferencing. Okay, so first off, we have to go and add our data frame for our coordinate systems. We have to go to geographic coordinate system. Now let's go to world. Now here we have to select WGS 1984. Now when we have selected this, still when you see it isn't like linked with my map. So we have to link that the WGS 1984 to this map over here. So for that, we have to firstly choose 4 points, 4 arbitrary points from this map. Let's say one is 37, 68. The second will be 65 and 37. The third point we will say as 32° north and 45° east. And the fourth point will be 68 and 32. Okay. So first off, we have to go to customize, toolbars, and add our georeferencing toolbar. So when you click on it, this toolbar will appear over here. Now what we have to do, we have to add control points. Okay. So for that, we first have to zoom to a relevant point that we want to pick. Let's say it was 37 and 68. So we'll zoom over here, zoom further. Now click on add control points like that. And now click on the middle. Okay. Now right click over the same point. Right click, and now we have to input DMS of longitude and latitude. So now we know it was 68 and 37. 0, 0, 0, 0. Select north. Okay. Now that is linked. You have to go to full extent. Now, if you hover over this one point, you can see there is written 39, and almost the points are now linked somewhat. Okay, 37, 68. Now we'll move to the second point. It is 75 and 37. Add control point. Click. Now right click. Input DMS. Now easting was 65 and 37. Similarly, we'll remove the 0, 0, 0 and 0. Okay. C5. Okay, I think I input a wrong number. It was
75,
75.
I think.
It was 75. A data map. Okay. Nothing. Okay. Full extent. Now select the second point, 75 and 37. Add control point. Input DMS 75, 37. Okay. Let's go back. Now the third point will be 32 and 75. Add control point. Click, right click, input DMS 75 and 32. Remove this 0, 0, 0. Okay. Now let's the fourth point, 68 and 32. Add control point, click, right click, input DMS of longitude and latitude. Now you can see it is almost the same now. We have just to edit this one, 32, 0, 0, 0 and 0. Now the first part is done. Okay, this point was 68.
Zarya bro,
I don't know
don't
what is wrong
make
with
the
this.
minutes and seconds 0. Let them be as it is.
Okay.
Yeah, you
In the
enter
fourth point,
67.
just leave the minutes and seconds.
I think I have to re-add all of them.
Zaryab, do you hear me?
Yes, sir.
There is there is a table in this georeferencing toolbar. You can delete one point which is not true. You can try that.
Yeah.
This is the
View
link
link
table.
table.
Yeah,
Yeah,
you
actually,
can
I
use this
went back
table.
now. That is all. That is all went. I
Okay.
cannot use that table again now because I selected the undo tab. Thirty-two and 68. Okay, this is set now. So now we have to go to georeferencing and update georeferencing. Now this map here is updated and it is in accordance with the actual map, with the actual real world. Okay, so the first part of georeferencing is done to georeference a map with control points. He has the control points, and now this map is georeference. Uh, let's, for checking purpose, let's hover on to 36 and 69. 36 and 69. And then you can see over here it is almost the same. The decimal degrees are almost the same. 36 and 69. So now this is, now let's suppose we are given a map which doesn't have these control points. Now, how will you georeference that map with no control points? So for that purpose, we'll take a map that is previously georeferenced, like this map over here. So let's add a map. Let's take this one, add. Now, you see here this Mardan map. It is not georeferenced. It does not have control points. So what we are basically going to do, we are going to georeference this map according to this map. Zoom to layer with this map. So the very first thing that you want to do is you want to go to Mardan, zoom to layer, and the very important thing that you need to do is go over here and select Mardan map. If you don't select this map, then the georeferencing for the previous map will be will be in continuous, and this map wouldn't be georeferenced. So you have to select this from here. Now when you select it, we have to choose 4 points, 4 points from this map that we are going to georeference with this one, with the Mardan map in this one, like this. So we'll select this point, 1, 2, 3, and 4. 1, 2, 3, and 4. So let's go there, zoom to layer. Now this is our point 1. So we'll take add control points. We'll zoom to this location, zoom in, zoom. Now add control point. Let's say we took this point. Now don't right click. Just when you click one time, you can see that this line is basically hovering with our pointer. Now go to this map, right click, zoom to layer, zoom in to Mardan map, zoom further and further. Now click add control points, and you can see that same line is moving with our cursor. Now choose the same point on this map. Now there our first point is geo-referenced. This point is linked to the other map. Now let's choose the second point. So zoom in again, add control point. Let's choose this point. Click. Now you can see the trail is going with our cursor. Now zoom again to the first map. Zoom to layer. Uh, we'll need to zoom out a little. Extend. Zoom to layer. Zoom out.
Mardan map.
Untick
Hide,
the
just
map.
hide the
Hide
Mardan
this
map
map.
so that.
Hide the Mardan 1 map. Untick it. Untick.
Hide the Mardan map from the layer.
Okay. Yeah. Thank you. Zoom to layer. Now zoom in. Zoom again. Now click on add control point and click to the same point that we previously selected. There. Let's go to Mardan 1 map again. Zoom to layer. Now you can see this map appearing on top of this map, up on top of our previous map. There you can see. Now this was our control point, reference your reference map, and the second map is appearing on top of our georeference map. So it is in reference with the Mardan map of the georeference map. Now let's zoom in again and select our for a third point. Let's say this is our third point. Now add control point. Let's select this point. Now select the same point on the previous one. Zoom out. Now you can see the third point is also linked. Now we are only left with the last one. So zoom to layer. Zoom into our fourth point. Let's say the fourth point is this one. Okay. Add control point. Choose point. Now when it is chosen and we set off this one, you can see that it is just over there. You just have to slide a little. Now select and select this point. Now if we zoom out, select update georeferencing. Now both of our maps are georeferenced, and if you unselect it and just go to this map, now this map is georeferenced to our first one. Like if you just go over here and put your cursor over here, put your cursor on the first point, and you can see the decimal degrees 71 and 34 right over here. You can see it. It is 71 and 34 almost. Now, if you want to verify it, zoom to the other layer and see that same point when you put it 71 and 34. Now, both of your maps are geo-referenced. And so this was our exercise for geo-referencing a map. Thank you, sir. Is there any question from me?
Excuse me?
Hello? Yes, sir.
Yes. Sir, how we can get the map from internet which is georeferenceable?
Okay. Now if you look to this one, if you search for Mardan map, this image will appear. Okay. Now this is an image, and if you go and look to this map, okay, zoom to layer map. Okay. Now this is also a JPG image. You can just go to Google Images and search for your desired place, and you can download a map from for there. If you go to this exercise maps, now you can see all of these are in JPG format. Okay, it is in JPG format, JPG file, and you can download any JPG file from the internet very easily. Just go to Google Images and search for your place, and you can download it from there. When you want to download an image with control points, just write in your keywords control points, map of Mardan with control points, and you will get the same map. Is it clear, Mr. Hashmatullah?
Yes, sir. Thank you.
Thank you. Is there any other question from my side? Okay.
No question.
No, thank you, sir.
Yes.
Rizwan,
Okay,
share
so
your
engineer
screen.
Rizwan.
Rizwan?
Zaryab,
Engineer Salman. Yes, Salman.
uh, should I start?
Yes, please.
Okay.
Okay,
Let me
let me
share
stop
my
sharing.
screen first.
Yeah.
Yeah, Bismillah ar-Rahman ar-Rahim. Could you hear me clearly?
Yes, Salman, we can hear you properly.
Yes, sir,
Okay.
we can hear.
Yeah,
First
go
of
ahead.
all, I would like to thank our respected teacher, Dr. Asif Khan, for providing us such an opportunity to share our knowledge and discuss many things on many perspectives. After that, I would like to introduce myself. My name is Salman Khan, and I'm doing my PhD in Water Resources Engineering from UT Peshawar, with my research area in hydroclimatic modeling techniques for climate change impact assessment on water resources, freshwater resources of Pakistan. Um, on priority basis, when we are dealing with different hydroclimate modeling techniques, there we need input data to to feed those models. And for that, we need some basic steps to prepare those data sets. And here, why I selected this very simple and basic exercise for discussion, that is extraction of data. That how could we extract data from raster data set, and how could we extract data from vector, or how could we extract information from vector by using another vector. So I would limit my discussion and practice exercise to the data extraction and how do we add Excel data to ArcGIS and analyze it. Okay, so let me open the digital elevation model. So our first exercise is the data extraction, that how could we extract data from raster data set by using vector data like polygon shapefile or point shapefile. How could we extract our desired information from a raster data set? So here we have a raster data set. Let me upload it. I'm having data for Pakistan. I'm having digital elevation model UTM1 DEM, and I'm having SILE UTM, and I'm having land use data for Pakistan. So these three are larger models for overall Pakistan region. So let me upload the digital elevation model for Pakistan, and you can see over here. But I'm interested, let for example, my area of interest is Mangla watershed. As I'm working on Mangla watershed, Mangla basin, so my point of interest is Mangla outlet, and I need to extract data for Mangla watershed. As when I will feed the model with my data, so I would need to add the data for that particular region which is contributing to the runoff at that particular outlet, which is Mangla. So let me upload the shape file of Mangla over here. You could see here, this is my area of interest, and I'm having this bigger data set, larger digital elevation model. Okay, so to reduce the processing efforts of the system, I would need to extract the data up to the limits. Now, how I could extract digital elevation model by using this vector data? Because this is a polygon shape file, you could see here, this is a polygon shape file, and having area of 33,466 square kilometer. Okay, and here you could see I'm having a raster data set, and you could have a look at the different information. I'm using the TIFF format, and it is having a special reference of WGS 1984 UTM zone 42N. It is in projected coordinate system. And let me check what is the source, the general information. You could see here, you could see the source, which resolution digital elevation model this one is. You could see here the cell size 91 cross 91. It means I'm using a 90 cross 90 meter resolution digital elevation model. We could have 30 meter cross 30 meter and 5 meter cross 5 meter. Even we could have 1 meter cross 1 meter resolution digital elevation model as well. But that is paid versions. So we have different methods for data extraction. First of all, a very simple and very, you may say, approximate method that you can go for extraction, that is extraction by graphics. You could see here on this very toolbar, if I select the rectangle icon, you could have many options like rectangle, polygon, circle, ellipse, and so on. These are different graphics. Let me try the rectangle graphic. I'm going to select this region and I want to extract data for my area of interest. So here I will have a graphic in rectangular format. Because this is my area of interest, so I want extraction of this digital elevation model up to these boundaries. Okay, so this is extraction by how I go for extraction by graphics. Now I have selected this particular region. So what I'll do next, I'll just go to this digital elevation model and I will right click on this and will go to data and export data. Okay, you could see here is the selected graphics. Okay, clipping. What we are going to do, we are clipping that particular portion from the digital elevation model which is required to me. Okay, so here you could name it accordingly. I would like to name it area of interest. Okay, and it will save in TIFF format, and here you could guide the folder where you want to save this. So I'm going to use to save this in GIS practice class, which is on my desktop. I'm going to name it area of interest. Let, for example, you could give any name. Let me add the folder first. GIS practice class. Okay. So I will have my extracted portion by the name of area of interest in the GIS practice class folder. Okay. So let me save this. Okay. So my operation is successful, and I got a message of would you like to add the exported data to the map is a layer. If you want to add the exported data, which you have already did in the previous step, to add this that particular data to this layer, you just select yes. If you don't want to add the data to the layer, select no. But let's see, I want to see the data which I have already exported. I want to add the data into layers, and I just want to look into it. Okay, so let me uncheck the Mangla poly shapefile, which was my shapefile, area of interest, watershed boundary, and I also unchecked the digital elevation model for Pakistan. Now I am just having the cover, the graphic. Let me delete that cover from here. And you could see here, I had the same particular region which I was required with my graphics. So let me zoom to layer, and I could see the digital elevation model for the area of interest, which is my Mangla watershed. You could see here. Okay, so this is one way of extracting data for your area of interest by using polygon shapefile. Another method of extracting the data from a larger DIM. Now in same way, you can use to extract data for your area of interest or this boundary for land use, and similarly for soil data, because these three are raster data sets. And here is how you could extract data from raster data set by using your shapefile, or um, by using special graphics. Okay, now that was a bit approximate method. Now I'm going to try another method for data extraction, which normally I preferably use while I'm doing extraction for data. So let me uncheck these first. We are having a digital elevation model for Pakistan region. Let me zoom to layer. Could you hear me clearly?
Yes, sir.
Yes, sir. Yes, sir.
Okay, okay, let me continue. So I'm having data for, I'm having digital elevation model for Pakistan, and I want to extract the DEM, the digital elevation model, by using this point shape file, which is Mangla watershed. Okay, you could have Tarbela watershed, you could have Chitral watershed, you could have Swat River basin, and so on. So it depends on in which area you are working. So now I'm having this shapefile, and I want to extract data by using this shapefile from this very raster data set. So what I would need to do, I will just go to uh, special analyst tool here. By using our toolbox, you just go to special analyst tool, and here you have an option of extraction, and your here you have number of options. You can extract data by circle, but for that you need to provide the coordinates, latitude and longitude of the central point, and you need to specify the radius of the circle in meters. Okay, so if you are having these two information, if you are having the coordinates of the center point, here is the x and y, and if you are having the radius, and then you specify the folder path where you want to save the new raster, and you want to extract the data inside the circle, or you can select the outside. Means you it will extract the data for outside of the circle if you select over here the outside option. Okay, so you can extract the data by circle, you can extract the data by mask. This is how you could extract the data by mask. I'm uploading the input raster, which is a digital elevation model for Pakistan. Okay, this is my input raster data, and my input raster or feature mask data. Okay, so what data I'm going to use as a mask that will ultimately clip that particular portion from the digital elevation model. So I can use my input uh, as a mask, that is Mangla watershed or Mangla polygon shapefile. So you could just give the path to the folder where you want to save the output raster, and just by clicking OK, you can extract the data for your area of interest. Let me save this over here by extraction. But here you need to remember one thing. Whenever I am going to provide the name, this should not be greater than 13 characters. Okay, if this is greater than 13 characters, you will have an error message over here. So this name by which you are going to save your extracted data, this should not be greater than 13 characters. Okay. Now let me let me just click OK, because I want to extract the data by using this shapefile. You could see here this is in process, and when it is going to complete, I will have a good news message over here. And this is what I have, extract by mask. So I have already extracted the data by using a mask, and it is already been added to my layers by the name I have said, extraction. Okay, so let me uncheck these things and let me have a look at into the data which I have already extracted. So you can see here, I have extracted the digital elevation model based on my area of interest, which was the polygon shape file for Mangla watershed. And now I can analyze this digital elevation model. Uh, uh, you could have a look into the properties where you could have an idea of the minimum elevation, maximum elevation, and standard deviation and mean value and so on. Okay, and you could particularly use this extracted data as an input to the different hydrological models which are based on raster data inputs. Okay, so this is another way of extraction. How could you extract data from raster data set by using a shapefile or a vector data? Okay, you can extract by points as well. Okay, let me input the raster over here, and if you are having the coordinates for your input points, you want to extract the data by using those points. You just enter the coordinates and you can come up with extraction by points. Okay, and so on. This is one way of extraction. Another way of extraction by using um, uh, vector data set, where you can extract the data from a digital elevation raster data set. Here in this particular case, this was digital elevation model. So in same way, if I use land use data, I mean, if I use a larger digital elevation model for land use, then you will be able to extract the data for land use. If I use and if I upload the global data for soil, which is also a raster data set, you will be able to extract the data for soil by using your polygon shape file for your own area of interest, and you will be able to analyze further the land use, soil, and digital elevation model for your particular basin or area of interest. Okay, now another extraction which I already mentioned, that was extraction of a vector information, vector data set, by using another vector data set. For example, let me upload the two vector data sets. Okay. So this was extraction of raster data set by using vector data. Now I'm going to extract information from a vector data by using another vector data. So how could you extract information or data by using vector data? So let me upload the, here we have, before going to do exercise for extraction of vector data, let me introduce you people with the data addition, that how could we add data into the ArcGIS. So here we have, I'm having an Excel sheet of uh, different points. You could see here Could you see the Excel sheet?
No, sir, it's a black screen, sir.
No, sir, one is not visible.
Okay, okay, okay. Let me. Is it visible now?
Yes, it's okay now.
Yeah. Yes, sir.
Okay. So let me add the data. I'm having a point shape file for for Zob Basin. So let me add the point shape file over here. You could see I'm having the point shape file. These are the number of points, different points. Okay. Let me upload the Excel sheet. So XLS. Here I have the data of latitude, longitude, and elevation values for different points. I just uploaded the information to the ArcGIS, and now I want um, to have these information in vector form, or you may say in vector format, which is shapefile. Okay, so let me define the geographical reference, which is WGS 1984. Word, and now WGS 1984. Okay, now you could see I will have number of points. You could see here I'm having a number of points for this particular region, um, and this is now in point shape file. You could see the attribute table. Here you have the latitude, longitude, elevation, and you could you can add another field where you could add another information like name, area, length, and so on. So you could do many things by using this. But keep in mind, if you are having latitude, longitude, elevation, or other information, and you want to import this data as a point shape file or a polygon shape file into ArcGIS, so keep in mind you must provide the first and second columns in Excel. These two columns should be reserved for latitude and longitude. If you are having ID or name over here in these first two columns, and then you start with latitude and longitude, so you will not be able to upload the data into ArcGIS, and you will not be able to have the shape file of that. Okay. Now I'm looking to have extraction for this. I want to extract some of the points from these bunch of points, and by using a shape file over here, now you can clearly see I'm having these bunch of points, but I'm only interested to have these points. Now, how could I extract this particular area? And let for example, this is my point of this is my area of interest, and these are different data points, and I only need those points which lies just under this boundary. Okay, so if I'm going to extract only those points which are inside my boundary or my polygon shape file, so how could I go for extraction? That is another way of extraction from a vector data set by using a vector data. Okay, so here you have Arc toolbox, and you just go to analysis tools, and here you have extract option, and when you click on clip, also you will pop up with this window. Here you input your feature. Now these are features on my layer. Okay, so I want to add the zoom points feature. Okay, zoom points feature, because if you could see here, all these points were named as zoom points. Okay. Here. And I want to clip the features, the vector data by using this particular Padinzai shapefile, which is my area of interest, because I only need these points, which is which is inside the boundary, and I want to extract those points only. Okay, just let me guide the flow path. I would like to name it the points BC. Let for the sake of argument, I'm going to save this by the name points BC shapefile. Okay. If I click OK, here you see this is in process, and I just got a good news message that your clip is successful. And now I'm going to you could see that the data is already been added to the layers. If I uncheck these, you could see here from the bunch of points, I got only those points which were just inside my boundary. Okay, you could see here this was my boundary, and I got only those points which comes just inside the uh, inside my boundary. Okay, or polygon shapefile. So this is how you could go for extraction of different data sets. Apart from this, I'd like to add regarding the projections of different data sets, that how you could have projections. Sorry for inconvenience. I'm out of station and I'm working with a older version laptop, so the processes are a bit slow. For example, you are having this shapefile, which is a polygon shapefile. Okay, you can read the attributes just by clicking the open attribute table, and you can have information regarding this, that which spatial reference this data set have. So you could see here, this particular polygon shapefile is having the WGS 1994 UTM zone 42 and reference, special reference. It means this is an projected coordinate system, but I want this in geographic coordinate system. So how I can convert this projected coordinate system of the polygon shapefile into geographic coordinate system. For that, I can use Arc toolbox again. You need to go to data management tools. Over here you could see data management tools, and after that you are having projections and transformations. So I just click projections and transformations. Okay, and after that there are two options. The first one is project, and the second one is define projection. If this data set had no projection at all, then I would click this option, define projection. Then I'd be able to define projection to to this particular data set. But as it has already having projected data, some special reference, so therefore I cannot go for defined projection, and I'm having an option for uh, to change or convert it from one projection to another. So I will just click on project, okay, and I will use the input data set by which I'm interested to change its projection, and where I want to save the class, I want to save the class and this particular data over here in my GIS practice class by the name of projected. You must remember this should not be greater than 13 characters, okay. So this one is projected, and now let me specify the output coordinate system, which coordinate system I want to assign to my area. So I want to assign a geographic coordinate system and a word, which is WGS 1984. So just let me click this WGS 1984, and now you just click OK. Here you have the processing window. It's the projection is in process. Once it's complete, I will have a prompt message over here. Now it's projected, and you could see here, if I'm going to upload that particular shapefile which I have already saved by the name of projected SHP. If I upload this, you'll have now you could have its projections. Let me zoom to layer it first. And now you could have its projections. It will be in geographic coordinate system. You could see here the graphic coordinate system, geographic coordinate system, its special reference, which is WGS 1984. And before over here, before projection, you could see here it was in projected coordinate system. That was UTM zone 42N. But now, as I change its special reference, and it is now in WGS 1984, which is geographic coordinate system. So you can play with many things by using our toolbox, and inshallah, as we go ahead with GIS classes, our knowledge regarding GIS and using different tools of GIS will go on deepen, and inshallah we'll be able to cover many more things. So this is from my side for today's discussion, and inshallah I hope you could have understand what I have tried to convey. If you have any questions, you can ask.
Okay, and thank you, Salman, and everyone who presented today. Let me reiterate a few things for those who were not able to take previous classes or who are new to the class. So what you have to do, there are class recordings available, and those class recordings will help you out to understand different aspects of GIS and to practice various available facilities within our tools within the same environment. I would just let you know about few things that, of course, like today, we were trying our level best to recall all those whatever we did in our previous classes. So in some, what we did introduction to GIS and remote sensing, and then we learned something about the projection systems and georeferencing of map from non-control point and map-to-map georeferencing. Then we learned digitization and how to add data in shape of points, lines, polygons, and how can we add attributes to those data sets, and how can we prepare a good layout or map at the end of the day. And similarly, we learned other tools, for example, intersection, union, merging, and buffering of different tools. So those are few of the basic tools what we learned, and it's everyone's responsibility to learn and practice those commands and tools. So what we will do, we'll have a quiz after Eid. Whatever we did till now, there will be quiz after Eid, and till then, happy Eid Mubarak, and have a blessed Ramzan. Thank you.
Thank you, sir.
Sunlight.
Thank you, sir.
Thank you, sir. Have a nice Eid.
Thank you, sir.
Thank you, sir. Sir, I will present you the review.
Rizwan, are you going to present something now?
Yes, sir. The intersection of buffer.
Okay. Sorry, I was assuming that Salman's was last presentation. So you should continue, Rizwan. I'm not going to interrupt whatever was planned.
Yes, sir. Okay. Thank you, sir.
Okay, thank you.
Share screen, share. Rezwan, on your mic.
Are you here?
Yes, yes.
No. First of all, I will add data to the GIS. Then right click on this, add data. And then add coordinates. You go to file and then add XY data. Click on this. No, these are temporary points. No, I want to convert its permanent point. Then right click on this. De go to data and then export data. Save it. Yes. These here are permanent data and these are temporary. No, then we will remove this temporary data. No, you have export particular shape file of a concerned particular basin, then right click on this. Add attribute table. Like we will select like scene. This and then right click on this. Go export data. These are the scenes file. No, let's assume these are to Belgium schools. No, I want all those to Belgium schools which are within this particular basin. No, first way by selection. Selection by location. Coordinates. These are scenes. Okay. Known is these are the pine which are in this basin. And then right click on this. Now these are into wells. Yeah, school. Save. Okay. we use the intersection to get the common data on this basin. No, go to analysis tool, click over there, then click intersection. Coordinates. And other is same. Okay. After completion, I will see what happened. Yes, it will complete intersection. Then see in this. Right click and see check its and I repeat for the next basin. This classes is called intersection classes, and then repeat for the other basin. No. Like click on this. And then right click. Save it. And then selection by location. Okay. Right click on this. Export this point to the basin. and then use the intersection. What in the other Punjab? Okay. These are no. After that, we have merged these two basins. No, then turn off all other except these two basins. Like selection tools. And then like click on this sport data. No, select these two basins.
Okay, sir.
Go to editor, then click start editing. Two basin, and then click OK. And then go to editor, click merge, then select any one Punjab Yasin, which basin you want to merge with the other. If we select Punjab, then Punjab parameter is prevent basin. Okay. They merge each other. Now, these are the process of merging. Any question related to this?
Okay, thank you, sir. It's
Uh,
enough for today.
Rizwan,
G.
what was this method card that you are performing? Can you please tell
These are
me?
merging
Okay, merging. Okay.
merging classes.
Okay, thank you. It's enough for today, I think.
And have you done the intersection process?
Section classes, yes.
So now which one is left?
These are intersection classes. First of all, you select basin and then select point to this basin. These are the intersection of Sindh and these are the intersection of Punjab.
Okay, thank you.
Any other question?
No, thank you, sir. It's time for Namaz.
Okay, thanks.
Liaquat sir, can you please turn off the recording?
Okay, I will.
Okay, thank you, sir.
Presentations.
Ya ahora.
Matava Pisan?
Oh,
Okay,
yes,
everyone. So I think sir has already left, and now it's almost time for prayer, so we can all leave the class now. Thank you. Thank you so much.
Okay.
Zaria, bro, you took the attendance in the beginning. Just check the attendance.
Hawaz
If
Khan, I
here
have
we might
taken
be.
your attendance. Okay, you're marked present.
Yes, yes, always the
Zaria,
attendance, take attendance after 30 minutes or 40 minutes of the class because most of the
I
students
take
join
attendance
after 10
after
or
every
20 minutes.
15 minutes. I take attendance after every 15 minutes whenever someone is online and he is not marked present, then I mark him present at the same time. Okay.
Okay, okay, it's okay. Okay, fine.
so Zaria, if you could upload the
Yeah. I look for
recorded
a time. I
video.
look for a time when everyone is when there are more people have joined the class.
Okay.
إذا تطورين يا سر.
Wow, मेरा भाई.
يرتبط ده زي مشكلة رمى ده GIS كي غدا. أنا زي كلا ده digitization كمان. أوري.
Wow, मेरा भाई. Aura.
digitization چې څه کوم نو زه چې کله digitization کې کله
Please
د
stop recording, Zaria Khan.
Zaria sir, can you stop the recording?
Sorry.
Recording. Stop
Recording is
recording.
on.
Please stop the recording.
Yeah, I have told Liaquat sir to stop the recording. I think he has left.
And kindly share the recording too in class.
Yeah, but I don't have the option to stop the recording. Check if any one of you have the option to stop the recording. Saliakat?
Rajab, with the class?
Yes, you can leave the class, Rizwan.
वो रिकॉर्डिंग तो वो सनदे बन सवी लेक्चर
Hidayat tasu to leave ke no mata option kidi Rashid recording ban kolo. Yau gore chicha sir
Save.
option we recording bandolon se agar recording band ki.
जी आप सारे लीव कर ले, रिकॉर्डिंग खुद बहुत बंद हो जाएगी। मैं भी मोबाइल से ऑनलाइन हूँ, लैपटॉप से कोशिश कर रहा हूँ, थोड़ा टाइम लगेगा।
ठीक है सर, थैंक यू।
ओके सर, थैंक यू।
Sir, kindly stop the recording of the class.
जी जी मैं साफ कर रहा हूँ, आप लोग लीव कर ले।